Imagine this, you find a 1 hour YouTube video that looks super interesting. Maybe it's a lecture, a podcast, or a tutorial. You click play and then 10 minutes in you realize you don't have the time to watch it all. That's exactly where AI can come in. What if you could instantly get the summary of any YouTube video plus the key ideas and even suggestions around it without wasting hours? Today I'm going to show you exactly how to build this using LangGraph, LangChain and FastAPI. So let's dive right in. Here's the workflow we'll follow step by step. Step 1, extracting the script. We'll start by pulling the transcript of any YouTube video using LangChain's YouTube loader. That gives us the raw text to work with. Step 2, summarization. Next, we feed the transcript into LangGraph and generate a clean human readable summary. Instead of reading a whole hour-long video, you get the essence in just a few lines. Step 3, finding keywords. From the transcript, we will also extract the most important keywords and key phrases. These highlight the video's core ideas and give us hooks for further exploration. Step 4, video suggestions. Using those keywords, we'll search YouTube and bring back related videos. This means that after watching one video, you instantly get a curated set of suggestions to go deeper into the topic. Step 5, generating questions. To make the experience more interactive, we'll generate thoughtful questions from the summary. Think of them as quick search checks or study prompts. Step 6, next steps. Finally, instead of just ending with a summary, we'll let the AI suggest practical next steps. For example, if the video is about React basics, the tool might suggest learning state management or hooks as a follow-up. And now it's time to bring this idea to life. So let's fire up VS Code and start coding. As always, all the docs and the complete code base are linked right below. Let's first create a virtual environment. Right now, all I have is a requirements.txt file to install the dependencies and my Groq API key set in the environment variables. Be sure to grab yours from the link given below. Next, select the Python interpreter by holding down Ctrl Shift and P. Activate the virtual environment and start by installing the required dependencies. Now, for building the graph, we will make use of base model from Pydantic for automatic validations. Create a new class called GraphState which takes in the base model. This will be the shared graph state across our entire workflow. Let's now define the fields of a graph state. First is a YouTube video URL which should be a string. Now, this is the only required input when invoking the graph, therefore, the rest of the fields will be optional with the default value of none. Please watch my previous videos on LangGraph and LangChain where I've used both typedict and Pydantic for further clarification. Follow along for defining the rest of the fields for our state graph. I want the LLM to output a deterministic result, so for that I will be making use of structure output parser from LangChain. So let's build a class for the structure output as well. And before I can do that, let's instantiate the LLM itself by importing chartgraph from LangChain Groq. Now, we have to create an additional node for extracting the YouTube video ID from the YouTube URL because the LangChain's YouTube loader was not working while I was recording this. So we will make use of the YouTube transcript API itself. For extracting only the YouTube video ID from the URL, you can have some custom logic with the help of regular expressions and all. But for now, I will just prompt the LLM to do it. We have access to the YouTube URL from the state. Import the prompt template from LangChain prompts and instruct your LLM to extract the video ID from the YouTube URL. Specify the URL as a dynamic input by enclosing it within curly brackets and passing it inside the input variables. Call the structure output on the class that we created for deterministic output. Next, create a chain and invoke it on the video URL. Now, we return the responses video ID inside the video underscore ID field of a state. Great, now it's time to extract the transcript for this YouTube video ID. Create a new function which takes in a state, access the YouTube video ID, now we have to call the YouTube transcript API for extracting the transcript from this URL, so let's import that first. Call the fetch method on the YouTube video ID and join the snippets that you get back from the transcript. Return the transcript text as transcript from this function. Follow along for building the rest of the nodes, as I believe you must have got a pretty clear picture as to what is to be done. Alright, now it's time to build the video suggestion node, which will search the YouTube on the keyword in a state graph. For this, head on to the link given below. You will be able to see a YouTube search tool, which is made available by LangChain. There are various tools that you can use to build AI agents. Now, these tools are built and maintained by community members, so they are available inside the LangChain community package. But for now, let's use our first tool, that is a YouTube search tool, to actually get some video suggestions on a keyword. Start by importing the YouTube search tool from LangChain community. Build a new function and access the keyword. Next, instantiate the tool and call the run method on the keyword. And done. That is how simple it is to connect external tools to your LangGraph workflows and make them dynamic. Great, now it's time to build the actual graph. For that, start by importing start, end, and state graph from langgraph.graph. Define the nodes as a custom defined functions that we built. Next, define the starting, intermediate and ending edges. Compile the graph and voila, the LangGraph workflow is built. To see this in action, let's make use of the LangGraph Studio. Create a langgraph.json file inside the root directory and specify the location of your graph. Open up the terminal and enter the command langgraph dev, which will spin up the LangGraph Studio for us. You can see that our graph has been displayed in a very nice interactive environment. Go on and give it an input. As the graph runs, you can see the working nodes being highlighted one by one. Now it's time to expose an API endpoint for this using FastAPI. For that, head on to the link in the description, scroll down and you will see a code example which will serve as a starting point for our FastAPI server. Import the graph from the main file and rewrite the last root as a post root which will accept a video URL of type string. Invoke the graph on that input and return the response. Open up a terminal and enter the command uvcon app:app with reload set to true. Head on to the expose URL endpoint, append /docs in front of it, and you will be able to see all your API endpoints being documented for you in a seamless manner. Click on a post root and try giving it an input. Hit execute and you will be able to see that we are now running the LangGraph workflow through our very own FastAPI server. You can use this to communicate between frontends, open source tools like Postman, etc. And that's a wrap. We've built a YouTube summarizer that not only gives you the gist but also keyword suggestions and next steps. If you found this useful, hit like, subscribe and let me know what I should build next. See you in the next one.